Good morning, class. Welcome to St. Peter's School. This is your science class, and this is our seventh class, I think. And we are studying the first chapter only, the laws of motion. And we all already have covered the different topics like what is speed, what is velocity, what is distance, what is displacement, what is acceleration, and what is uniform velocity, what is non-uniform velocity. So we already have covered all this topic. All these terms should be clear to you. Okay, so there is no confusion. If you are having confusion, you can you all are free to ask me anytime on the any topic. Okay, so now in previous class I have given you some questions related to the topic speed, velocity, and acceleration. Hope you all have done all those questions and all the answers given by you are very much correct. So let's have a look on the answer of those questions. So let's move to the that slide in which I have given you the question. Okay, so this is the first question I have given you given in the last class, that is filling the blanks related to speed, velocity, and acceleration. So first question is that dash is defined as the total distance traveled by the body in the time interval during which motion takes place. Now, what is this? If the body is moving in a given interval of time, so what is the like total distance traveled by the time? What is that? That is nothing. It's a speed. Okay, speed is defined as the total distance traveled by the body in the time interval during which motion takes place. Why we are not writing velocity here? Because the body has like it's a total displacement, not it's a total displacement, it's a total distance. um, and you will see that in the end of the line it's written here during which the motion takes place. It means that if the might be the body is moved and it's again comes to initial position, there also the speed is something we can calculate the speed. But in that case velocity might be zero, even if there the body is in a motion. But if there is a body is in a motion and it comes on the initial position also, but we can calculate, we will calculate speed in that condition. Now second question is dash unit of speed is meter per second. So we all have studied about what is the SI unit and what is CGS unit. Okay, so what is this? This is as in the unit it's written meter, so it's not kilometer. So what it will be? It will be SI unit. Okay, the ratio of total distance to the total dash taken by the body gives its average speed. We all know how to calculate the speed. It's the ratio of total distance by total time. Okay. Fourth question, the rate of change of displacement of an object with the passage of time is known as dash of an object. So if as the question itself defines that the rate of change of displacement, it means if the body's displacement occurs, it means velocity occurs, right? There is speed also occurs, but velocity also occurs. So time is known as the velocity of the object. Okay, because the term displacement is written here, not the distance covered by the body. Okay, velocity of a body, fifth question, move to the fifth question. Velocity of a body is vector quantity involving both distance and displacement. Velocity of the body is known as the vector quantity because it has also covered the distance, but it has a fixed direction, that is called dis distance covered in a fixed direction, that is called displacement. Okay, whereas the speed of the body is a scalar quantity and it is no only has a magnitude, does not have a specific direction. So that's why speed is known as the scalar quantity while velocity is known as the vector quantity, because though it is cover distance, but in a fixed direction, that is called displacement. Okay, so now next question, move to the question number 6, that is a body is said to be moving with uniform velocity if it covers equal distance in equal interval of time. Yes, so that type of and the body is moving in a uniform velocity and in time in a specified, as the question itself defining the answer is that a body is said to be moving with uniform velocity. So if there is a body, if we are calculating here the uniform velocity, it is self-defined that it covers equal distance in equal interval of time in a specified direction always. Okay. Otherwise, it not be considered as a velocity. It will considered as a uniform speed if there is a no specified direction. Okay. Seventh question is a object is said to be moving with non-uniform velocity if it covers covers unequal distance if it covers unequal distances in equal interval of time and vice versa in a specified direction. Okay, so sorry, I'm so sorry. What is the question? Okay, so direction for it changes the direction of dash. Okay, so let's read out this question again. Object is said to be moving with non-uniform velocity if it covers unequal distance in equal interval of time. So what is written here? Unequal distance in equal interval of time, that is known as non-uniform motion. Okay, and vice versa in a specified direction, or if it changes the direction of motion. Okay, the answer will be here motion. An object, what do you understand by this? This is called yes, if the body is moving with what is it called, if the body is moving with the uniform velocity with unequal distance but equal interval of time, that is means that body is in a motion. Okay, so seventh answer will be motion. Last question, 8. If acceleration is in the dash of velocity, then it is positive acceleration. We have studied about what is positive acceleration and what is negative. If the acceleration is in the direction of velocity, means like if the velocity is changing, um, like for example, if the velocity is increasing, means it's a positive acceleration in the direction, in direction should be same, if right, and if it is in the dash opposite, so what will be that? Direction opposite to the dash of the velocity, then it is negative. Opposite to the velocity, then it will be the negative acceleration. Okay, so in eighth, what is the answer? Direction. And again, there is, if it is in the opposite to the direction, it is in the velocity opposite, acceleration opposite to the direction of velocity, then it is negative. Okay. So in eighth, first will be here, it will be direction of the velocity. If it is in the acceleration opposite to the direction of the velocity, then it is known as the negative acceleration or the retardation. Okay, now move to the next question, that is first, that is true false only. Acceleration is measure of a change in the speed of an object per unit time. What is it? True or false? Acceleration is a measure of change in the speed. No, not. It's a false, because acceleration is nothing. It's a change of velocity. Okay. Second question. A body has non-uniform acceleration if its velocity increases or decreases by unequal amount in equal interval of time. Yes, it will be non-uniform because velocity because increases or decreases by unequal amount in equal interval of time. Unequal amount means unequal distance covered. Okay. Third one is when velocity of the object changes at a uniform rate, then the average velocity is given by arithmetic mean of initial velocity and final velocity for a given period of time. So when velocity of the object changes at a uniform rate, yes, the average velocity is given by arithmetic mean of initial velocity and the final velocity. Yes, it's a true. Like we can calculate in that case initial velocity and final velocity by to calculate their rate of changes. Yes, now fourth question is so third one is also true. Fourth one is the velocity of a body can be changed into two ways. First by changing the speed of the object, and second by the changing the direction of the motion. So we have studied this point when we were studying at the that example, the motorcycle biker is like changing, sometimes changing the speed and sometimes changing the direction. So that is the same example. So it's true, the velocity of a body can be changed into two ways, either by changing the speed or either changing by the direction of the motion body by keeping the speed constant. Okay. Fifth is the odometer in the car measures the velocity of the car. No. What it calculates the speed of the car. Odometer is in the car measures the velocity of the car. No, false. A object is said to have a constant or a uniform velocity if it travels equal distance in equal interval of time. So it is called uniform velocity, equal. Okay, so sixth one is an object is said to have a constant or a uniform velocity if it travels equal distance in equal interval of time. I think it should be here a displacement. So might be it is false. Okay, an object is said to have a constant. So check in your answer in which I have given you on the next slide. What is the answer of all these questions? So might be it will be false because it is written here the velocity and it is written in equal distance equal to that is called speed. A body has uniform acceleration if it travels in a straight line and its velocity increases by equal amount in equal interval of time. A body has uniform acceleration if it is travels in a straight line and its velocity increases by yes the I have given you related to this this sentence I have given you one graph. I have shown you that what will type what is the type of graph in that case when the body is moving in a uniform acceleration, it travels in a straight line. Its velocity increases by equal amount in equal amount of time. So it's false. Why it's false? Because our body is uniform acceleration if it travels in a straight line and its velocity increases by equal. So no, there will be no increase in velocity. If there is will be an increase in a velocity, there is we are not able to get a uniform, we are not able to get a straight line. Okay, so always in the case of uniform we will get a straight line, but if the velocity will be changed, it means that it will not cover a uniform distance or uniform motion, but is not in a uniform motion. So seventh one is also false. Now, let's move to the next topic. So now, I will request again all the students, please take out your books and keep in front of you. Take out page number 7. Okay. Okay. So we will start only one point we will cover today because we have already solved the questions and here the answer I have given you the that of all those questions. So just match your answer and calculate how much you understood all the points. Okay, now move to the next topic, that is velocity time graph. The variation in the velocity with time for an object moving in a straight line can be represented well by a velocity time graph. Velocity time graph is nothing, it's a it's the graphical way to show the changing of the velocity with respect of time. Okay, in this graph time is represented along the x-axis and the velocity is represented along the y-axis. In this case of in the previous class we studied distance diagram for the non-uniform motion. In the same way we are in the same way we will understand here also on the graph that y-axis axis and the time is represented on the x-axis and distance is represented on the y-axis. The product of the velocity and the time give displacement of an object moving with uniform velocity. Okay, so the product of velocity and the time displacement of an object moving with uniform velocity, the area enclosed by the velocity time graph and the time axis will be equal to the magnitude of the displacement. Now what is this? It means that okay, so understand like this, the product, what it's saying that when we will measure both the distance and the displacement, we will not use the term here displacement because we are calculating velocity, so we will always use the term displacement. So displacement occurs by the body and the time. By the help of that, we can calculate the velocity. The product of velocity and the time, so product of the velocity and time gives the displacement of an object. What does it means? Like if you can say you can understand in the simple way like we know that velocity is equal to displacement by time. So we know that how the equation if the time we will take a time in the opposite you can say like we will move time to the right hand side. So what will be the equation now? Velocity into time is equal to displacement. So this is the same term what it's explaining this line. If a body moves with a constant velocity, then velocity time graph for this body would be straight line parallel to the time axis as shown below in the figure. So let's move to the figure only. Okay, so first figure it's given here velocity time graph. Okay, so you can see here, if the velocity time graph when speed remains constant, it means that there is no changing in the place of the body So what is this? That velocity will be also the same at the every equal interval of time. We have seen in the case of uniform velocity or uniform speed also in the previous class. In the same way, velocity is also related. If the velocity time graph showing the uniform acceleration, but velocities increases in the same way as the time increases, there is there is a equal interval of distance displacement, sorry, and there is a equal interval of displacement with respect to time, then there will be we will get a uniform velocity graph. Okay, the velocity time graph of uniformly changing velocity is shown in figure 6, and it is a straight line. We can find out the value of acceleration using the velocity time graph. Okay, so why we are studying actually this, what we can do, we can change, we can calculate the acceleration also by the help of this velocity time graph. Okay, so why? Because acceleration is nothing, it's a rate of change of velocity per interval of time, that is called acceleration. So that's why if we know how the velocity is changing with respect to time, we can also calculate the acceleration. For calculating the acceleration at the time corresponding to the point r, draw a perpendicular rp from the point r as shown in figure 6. We know that a is equal to change in the velocity by time taken. Here, change in velocity is represented by PR and the time taken is equal to OR. Okay. So, what is that? Acceleration is equal to change in velocity. What is change in velocity? PR, TR by OR. Okay, why it's showing that it's the total changes occurs in the total displacement covering. This is the total changes cover all the in the equal displacement, like in equal displacement. This is the total changes occurs in the velocity. So we are considering here that what is the velocity? This is PR, and this is the time taken by it, that is OR. So how we can find it? Acceleration is equal to PR by OR, which is equal to the slope of velocity time graph. So we can calculate that the slope of velocity time graph of body is the acceleration. Now, what is this? If you will remember this Pythagoras theorem, or I might be you have studied the Pythagoras theorem, so we can calculate now this, because we have a value of PR and we have a value of OR. So what is this? This is nothing. This is the acceleration graph, acceleration line. Okay. Okay, so this slope is representing acceleration. The distance traveled by the moving body in a given time will be equal to the area of a triangle OPR as shown in figure. Okay, so what is that? Distance traveled of moving body in a given time will be displacement. It's showing displacement. When the velocity of a body changes in an irregular manner, then the velocity time graph of the body is curved line. Okay, we are getting here a straight inclined slope, but if the body is moving in a non-uniform way, it we will get a curved line. Okay, so we will again discuss all these point in the next class. We have example also on the page number 7. So we will discuss this example in the next class. Till the time, keep revising all the point. Okay, take care. Bye bye.